recording. It's working? Y'all all got your packets out? And those who need it, you will have one before the day's over. So, all right, sorry about that. So, yesterday, Joshua, I'll throw a bone. I'll throw you a bone here. You're on video now. Yeah, like people can hear you now. So when like you're not doing great in class, and they go, "Why is my child not doing great?" You're just horrible teachers. Be like, "No, listen." Derp, 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 derp. I mean, they can hear you. So pay attention. Okay. So yesterday we talked about inductive reasoning. So without looking at your paper, take your hand and go cover it. Don't look, cheaters. Cover it. Describe to me inductive reasoning. Go.
An observation.
That's
making
very
an
general.
Observation. Wait,
Making
yeah.
an observation based. No, you're making a conclusion based on observation. Or something.
You read it. You told me.
Or something like that. I mean, it's word for word. Making a conclusion based on an observation of patterns and behaviors. What was my one analogy I gave you yesterday? This wasn't on your paper, so.
Yeah, so we can't cheat now.
Can't cheat. What was Jack? Remember, you got to work by yourself. Oh, it's pretty. All right. So, what was my analogy that I gave you?
I thought I made up the word analogy.
Wait for somebody.
Analogy to what?
For inductive reasoning. Huh? It's a person, but yeah, close enough.
Oh,
That was one. Yeah.
We concluded that person.
What else? What other analogy did I use? That's another analogy that I use. The hurricane. Hurricane, right? The computer like reads a bunch of different readings and all, and makes a prediction where they think it's going to go. So, inductive reasoning is kind of like making a prediction into the future based on the patterns we're seeing now. What is the conclusion that we reach from inductive reasoning? What's it called? What? Huh? There you go, conjecture. Right. So, and we went through, looked at some patterns with some numbers yesterday, and we determined a truth value. Oh, no, I'm sorry. We made a conjecture. So today, we're going to go a little further. Did we get to the backside where we was talking about any of this? All right, so did I give you the definition for a counterexample?
Yes.
Okay, good. All right, so I remember now because we talked about a few of these, didn't we?
Yeah.
Okay.
The first two.
The first two. Okay, so this one, the third one. The product of two perfect squares is always a perfect square. What's a perfect square?
A number that has a square root.
Well, every number has a square root.
Or like an actual.
Like when you take it
I'm
square
not
root.
good at explaining.
All right, so is 25? Is it a perfect square?
Yes.
Okay. Is 9?
Yeah. 3 by 3.
Yeah. Is 4?
No. Yeah. 2 by 2.
2 by 2. Right. All right. So let's see. Product of two perfect squares is always a perfect square. All right. Let's see. 4 times 9?
36.
Is 36 a perfect square?
Yeah.
No.
Could be. Let's try this. Is 36? 6 and 6, right? Okay. Is 100 a perfect square? Is 225?
I'm pretty sure.
Yes, it is. It's true.
What's the square root of 225?
15.
Yeah, very good. All right, so take 100, multiply it by 225.
Oh, that's a syntax error.
What?
That's probably something I did. That was probably not a mistake.
That's right.
So 100 times 220. So basically add 2 zeros on the end, right?
Yes.
So 22.5, is that a perfect square?
Yes.
Is it 50?
150.
150? Okay. I thought 50 is, okay. So, does it look like it's holding true?
Yes.
All right, now, let me ask you this. Is 1/4 a perfect square?
Yes.
Yes. Yeah.
What's the square root of 1?
1/2. Or half. What? Repeat.
What's the square root of 1?
Oh.
1.
1. What's the square root of 4?
2.
2.
So, it's 1/2, right? Yeah. All right, so, is 1/9? Is, yeah, 1/3, right?
Yeah.
What's this multiply together?
Oh, hold on.
Don't use your calculator. Don't you cheat.
I don't like fractions.
I don't know how to do fractions. Like I got like.
Every number's a fraction.
136.
Yeah, 136. Guys, you multiply straight across. That's it. Do what?
No, that's when.
If you're adding or subtracting, you don't multiply across.
Yeah, I don't know how to do that.
What did you just do? Multiply?
Yeah. I said product of, right? All right, so let's move onward. Carry on. All right, so we're going to this one today. We're talking about compound statements, truth tables, and truth values. So a lot of notey stuff here today. So the first one, your statement. Okay, the first line here, sentence that is either true or false. I'll wait for y'all to start writing that. True or false? Okay. This is called a truth value. So that's your second line. And we use, so instead of always writing out if we're doing these truth statements, instead of rewriting the expressions every time, that can be exhausting, we just abbreviate them. So we generally use P and Q. So y'all are familiar with statements like this, right? Like if the sun is rising in the east, then it is
Setting in the west.
setting in the west, or it's morning time, right? If sun,
That too.
that too. So are y'all familiar with if-then statement just on a basic level?
Yeah.
You use them all the time, right? So if you don't show up for class with your stuff, then you will not have good notes, or you will not pass. All right, so you use them all the time. So the if statement is usually denoted by the P. The Q is the then statement. That's not in there right now, but I'm just making you aware. So with this example here, my P statement, supplementary angles have a sum of 180. Is that a true statement or is it a false statement? True. So your truth value is, well, it's true, or you can put a T. Doesn't matter. All right, so your second thing, a negation. That is, so a negation of a statement has the opposite truth value. And you use this little symbol right here to denote a negation.
What are those things called? Do you know?
I know what they're
Squiggly.
called in like Spanish.
Yeah, I'm taking Spanish. I'm failing. So.
Sorry. Well, hey, it's not Spanish, so all right. So it's read as not P, but in my second period class, they decided to call it squiggle P. So
Oh.
it's really not is what it represents. But squiggle P sounds funnier. So with our example, not P. Okay, supplementary angles do not have a sum of 180.
False.
That's a false statement. Yes, that's right. That's right. Okay, so your next one right here. Compound statements. Ready? I'm just going to read this out. I'm not going to write it this time. Two or more statements joined by the words and or. You should be right. You have paper, don't you? My printer's messed up. That's. So two or more statements joined by the words and or. Do I need to say it one more time, or are we good? Good. All right, so a conjunction. Statements joined by the word and we use this little symbol right here to denote and. Huh? I did not hear a word you said.
That's in English.
Oh, conjunction? Oh, yeah. Conjunction,
I don't
function.
know. Math class has been reminding me a whole lot of English class recently.
Oh, yeah.
You're not suggesting that they might have some intertwinings, are you?
I feel like
If they do, then I will be very surprised because, like, I'm doing pretty good in English, and
So sometimes our terminology overlaps. Sometimes, but we are actually two very different disciplines.
a lot of vocabulary.
Huh? Use the symbols. Well, mathematics itself has its own language. Like literally, we have a language. So that's just a symbol we use. So conjunction. Use a little. It's actually a little chevron-looking symbol, and it's true. The statement will be true when both statements are true. Okay, both statements have to be true. We're going to see an example of that in a second. A disjunction. They're joined by the word or. Do you think you can guess the symbol they use?
it's going to be pointing down.
Yeah, you got it. Looks like that. And it's true when at least one statement is true. It's always a comforting sound. Initiate sequence. All right, so let's look at some of our examples here. So on our examples, they give us three statements, a P, a Q, and an R. So let's look at the first one. The P statement. There are 7 days in a week. Is that a true or is that a false?
True.
Yeah. So if you want to put like next to that like a T, just so you remember that. The second, the Q. March has 30 days. False. Yeah, you're right. That has 31, right? I remember the little thing with the knuckles.
I don't remember that.
Would you believe it wasn't until a couple of years ago? See, I just memorize things. I just know the calendar. But a student actually showed me that. I thought that was kind of cool. I'm like, See, every now and then I get taken to school. All right, so the R. Halloween is on October 31st.
Is it on the 30th?
True. True. It is. True. Isn't there some debate about trying to get that moved or something? I thought I heard something
What
somewhere.
is Halloween for real though? Like, is there actual
Day of the
holiday
Dead?
you gotta keep
No.
on the
It's
31st?
Day of the Dead.
That is not.
I could go on for it, but no. Let's stay on track. So with number 1, what does the little chevron mean again?
True.
Both
It
statements
means
are true.
PQ.
But both statements have to be true. Is that a conjunction or is that a disjunction?
A conjunction.
Conjunction.
Conjunction. All right. So when I'm going to write out my statement here, the P being the first one, right? I'm going to say there are 7 days in a week, and March has 30 days. Does that make sense?
Yeah.
So yeah. Are you writing? I will repeat. Yes, I will. So with that P, that little hat symbol, and Q, let me scroll up just a little bit. Right here, there we go. So this one right here. The first statement, there are 7 days in the week. That is the P statement, right? The little chevron symbol, and then that means and March has 30 days. That is your Q statement. So what's the truth value? False?
Is a disjunction.
No, it's a conjunction.
Wait. Wait, I thought March didn't have 30 days.
Exactly,
March
that's
has
why
31.
truth value,
Get on your notes.
Oh, okay, okay, I got
It's an and, right?
yeah.
Yeah, I got you.
remember what it was.
It's been a couple of years. So this statement was true. This one was false. If it's a conjunction, they both got to be true. So your truth value is
Disjunction.
false.
Wait, how many days are in March? I'm so confused.
31.
31?
Yeah.
Yeah.
Okay.
I suppose they could have made that a little bit. March is made of 30 days. Well, no, it's 31. I mean, I guess they could have technically. All right. So the second one here. How would I write that statement? Is it a conjunction or disjunction? Conjunction. All right. So how would I write that?
March has 30 days, and Halloween is on October 31st.
There you go. That's right. So what's the truth value in that?
False.
It's false. False. So number 3. Well, that'd be there are 7 days in a week, and Halloween is on the October 31st.
Yeah.
Is that a truth value of true or false? True. Yeah. There you go. Let's take a look at 4 here. I'm gonna do the first one here, and then I'm gonna let you do the rest of them. Because even down there on the bottom, you actually get to create your own. So, this one, what does the little squiggly mean? Not, right. So it's the negation of whatever P is. So what was P? There are 7 days in a week. How am I going to negate that? There you go. You got the idea. It's called a negation. Yeah, you negate whatever it was. So if I say, for instance, like if I said, hey, class ends at 3 o'clock, and I said negate that, you say class does not end at 3. That's all it
It's
means.
just the opposite.
Yeah, it's just the opposite. Yeah, that's all it is. So, what was that? 7 days a week? So, and or?
Or.
And.
Wait, why is that?
That way. And what was the Q? I forgot. Q was March has 30 days. True or false? False. That's right. Mm-hmm. I want you to try the rest of that page. So when you go 5 through 8, you're actually working off those 3 statements they gave you. But 9 through 14, you write your own P, Q, and R statements. It doesn't matter what they are. You write those, and you fill in the rest. So we'll go a few minutes. I'm gonna see if tell me if this thing pauses. All right, so let's run over them real quick, guys. Let's see how we're doing. So for the sake of time, I'll call out the 5 through 8. Right, 5 through 8. Mm-hmm. Yeah, and give you the truth that, and let's make sure that we're all on the same page. Right. So number 5 is P or R. Right. Mm-hmm. Okay. So there are 7 days in the week, or Halloween is on October 31st. Is that what you got as far as your statement? Okay. So with an or, only one of the statements has to be true.
Oh.
Okay, only one of them. So, I mean, if both are, then great, but only one of them has to be. So, is the first statement true?
Yes.
Yeah. Is the second statement true?
Yes.
What's my truth value?
True.
True. There you go. All right, number 6. Not Q or R. So, March does not have 30 days, or Halloween is on October 31st.
This is
So
number
it's true.
6.
6, yeah.
So there aren't 30 days in March?
See, March does not have 30 days. Hang on, let me make sure I'm reading the original statement right. Yeah. Or Halloween is October 30th. So at least one of them's true, right?
Yeah.
Yeah. When you're joined with the word or, yeah. All right. Number 7, not P or not R. So there's not 7 days in a week, or Halloween is not on October 31st.
It's false.
False.
Because they're both wrong.
So there are not 7 days in a week. Statement true or statement false?
False.
False. Halloween is not on October 31st. True or false?
False.
So neither one of those were true, were they? Okay. So false, right? Number 8. Not P or not Q. So there are not 7 days in a week, or March does not have 30 days.
It's true.
Which one?
March does not have 30 days.
March does not have 30. March has 31, right?
That's true.
So that one statement being true makes it true. Does that help? Yes, I'm sorry. Go ahead.
So like on those things I was like Halloween and or R and that's over here. They're both true and false.
Say it again. I'm sorry.
It says like so
Guys, y'all listen.
with the or word, if they're both true, it's false. That's not true.
On number 6, 6 is true.
Okay. Now you fix it.
Right, because March does not have 30 days. That's a true statement. It has 31 days. Yeah, and the other one's true. So with the or, if both of them are true, great, it's true. If one of them's true, then the truth value of that is still true. But if both of them are false, that's when it's actually false. Right. Where we at on time? Oh, we're getting about 4 minutes.
4 or 3.
3 or 4. Hey, real quickly, I know we're pushing it. I know, but let's take a real quick look at the truth table so I can at least kind of get you going. So with truth tables, so if I have a negation right here, if my original P statement is true, then what's the negated?
False.
Right? If the original P statement is false, what's the negation?
True.
Makes sense so far?
Yeah.
Okay. So P and Q. We assume the P and the Q are both true.
It's all true.
So this right here means and, right?
Yeah.
What is my statement then?
True.
True. Because both of them are true. They both have to be true, right? If the P is true, the Q is false.
It's false.
False, because it's an and, right? This is an and. False, true.
It's true. Wait, what is it?
And, it's still an and, right? False, false.
True. I mean,
False.
Wait, that makes no sense. Because they're both false.
Okay.
In a way, they're right, so
Hey. No. Still false. If it's false and if it's false, then the whole statement value is false.
It's the opposite on the other.
But it's a real.
Well, be careful here. All right, this is or, right?
that's right.
If are both of them true,
Yes.
then it's true.
Yep.
If one of them's true,
True.
if the other one's true,
True.
if both of them are
False.
False.
True.
That's technically, it's a true statement, but it's a false value.
Yeah.
right, false value. Yes, that's the better way to say it. You're right. All right,
This is not how
that's enough. So we'll stop.